A uniform bar, a uniform lever 4 meter long is pivoted at its midpoint. A load of 120 Newton is placed 0.5 meters from the pivot on one side. Calculate the effort required to balance the lever if it is applied at the far end of the other side. Now, to quickly solve this question, all we need is to illustrate this. Let's take this as the lever which is 4 meters long from this part to this part, 4 meters. Now it is pivoted at the midpoint. Midpoint means middle of it. Middle of 4 is 2. That means this is a pivot. Pivoted at the middle. Good. Then a load is placed at the far end, which is the effort. The effort is placed at the far end from the pivot. This is effort, while the load is placed 0.5 meters from the pivot. 0.5 meters from the pivot. 0.5 meters. So from here to this part is 2 meters. So if you subtract 2 meters from 0.5, this becomes 1.5 meters. Then here you are going to have the load. The load is 120 Newton. Now if you look at this, this is anti-clockwise and this is clockwise. Here, distance from here to this place is 2 meters. So therefore, if you follow the principle of moment, from the principle of moment, you have sum of the clockwise moment equals to anti-clockwise moment. So the clockwise here is the load times the load distance, load times load distance equals to, on the other side we have the effort times effort distance. Then here the load is 120, then the load distance is 0.5, 120, 0.5, and the effort is at this point E2, then the effort distance is E times 2. The next page, so I'm going to have 120 times 0.5 is 1 over 2, then equals to 2e. 2 in this gives 60, so 2e, twice of the effort, is going to be 60 divided both side by 2, then the effort is going to be 60 divided by 2, so the effort applied is 30 Newton. Let's proceed to the next question. A stone is thrown at an angle of 30 degrees to the horizontal with an initial velocity of 20 meters per second. State the value of the vertical component of the velocity. To get the value of the vertical component of the velocity, recall that in projectile motion you are dealing with two axes. The vertical component and the horizontal component, where you have your resultant here, which is u, at an angle which is angle alpha. So if we cut this down, if this is ux, this place is going to be u of x. If this is u of y, this place will be u of y. If this is alpha, this other angle here will be alpha y. Alternate angles are equal. Then this is perpendicularity 90, then 90. Bring one of this angle out. Have something like this: u, ux, uy, then alpha. So if I use trigonometric identity, so since we are looking for the vertical, the value of the vertical component, So vertical component is the u of y. So I have to resolve u of y. If you resolve u of y using SOHCAHTOA, that means u of x is not needed in this question. So you are working with opposite over hypotenuse. Opposite over hypotenuse will give us sine. So I have sine alpha equals to opposite is uy, hypotenuse is u. So we are looking for the value of the vertical component, which is uy. So uy is going to be u sine alpha. So u in this question is 20, then times sine of alpha, which is 30 degrees. Sine 30 is 0.5, which is half. So half of 20 will give 10 meter per second. So therefore the value of the vertical component of the velocity is 10 meters per second. The value of the vertical component of velocity, which is the initial velocity u of y, is 10 meters per second. Okay, quickly again, the next question. A ball is kicked from the edge of a cliff with a velocity of 15 meters per second. The cliff is 45 meters high. Then calculate the time taken for the ball to hit the ground, one. Then the horizontal distance covered before it lands. Two things here. Height of the cliff. Height of cliff is 45 meters. Then a ball is kicked horizontally from the edge of a cliff with a velocity. So the velocity given here is horizontal velocity. So horizontal velocity, which is ux, that is 15 meters per second. Then calculate the time taken for the ball to hit the ground. So for we to calculate the time taken here, note, for the time taken you have to go through the equation of second equation of motion, h equals to ut plus half g t squared. Now this u here represents the vertical component of velocity, which is u of y, but this object is projected horizontally, so vertical component of velocity is constant, which is 0. So h here will be 0 multiplied by this turns to 0, 1 over 2 gt squared. H has been given as 45, so 45 equals to 1 over 2 times gravity is 10, then multiply by t squared. 2 in this we give 5, so I'm left with 45 equals to 5 t squared. Then divide both sides by 5, so our 45 divided by 5 equals to 5t squared divided by 5. 5 cancel 5 in here, 9. So you have t squared equals to 9, which shows that t is square root of plus or minus 9, which will give 3 seconds. That's if this gives 3 seconds, then we'll proceed to the next page of the question, which is the horizontal distance covered. How do we get the horizontal distance covered? Horizontal distance covered, horizontal velocity is horizontal distance divided by time. So we also look for the horizontal distance. So horizontal distance, which is x, equals to horizontal velocity times time. So horizontal distance x, horizontal velocity in the question has been given as 15 meters per second, 15 times the time, which is 3. So distance, which is the horizontal distance, will be 15 times 3, which is 45 meters. So the horizontal distance is 45 meters.